Standard 8 Maths Chapter 6 Squares and Square Root. Hello everyone. So last video we have completed up to question number 4 of 6.4. Now we'll start with question number 5. Exercise 6.4, question number 5. So it says find the least number which must be added in each of the following numbers so as to get a perfect square. Also find the square root of the perfect square so obtain. So in the last question we have subtracted. In this question we are going to add the number to make it a perfect square. Fine. So the first number is 525. Okay. So we will do so what is the number? This is 2. Square root 2 is 4. We'll get 125 and double of 2 is 4. So if we see this be 129, we cannot take 129 because 125 is less than 129. So we'll go with this 42. So we'll write 42 here and 84 here. Okay. So the square, this 525 is greater than square of 22. Okay, is greater than square of 22. Square of 22 is what? 484. So it is 525 is greater than 484 and it is less than square of 23. So square of 23 will be 529. Yes. Yes, it is greater than square of 23. So this is 525 and square of 23 is 529. So what is the digit? So the next perfect square number will be 529 and we have 525 with us. So we will subtract this 525 from the next perfect square number, that is 529. We will get 4. So 4 we can add 4 to 525 in order to get the perfect square. So perfect square will be 529 and square root will be 23. Square root of 529 will be 23. Clear? Next question is 1750. 1750. This is, put the bars like the normal division method you do. This is 4. Square of 4 is 16. This is 8. 150. So it is 81 8 times because 82 will be so we will write 81 and this is 9 and this is 8. Okay. So this 1750 is greater than square of 41 and it is less than square of 42. So square of 42 is, just calculate, is 1764. So it is less than square of 42. So square of 42 is, this is 1750 and this is 1764. So we just subtract 1750 from, so the difference between these two will be 14. So 14 is the smallest digit that has to be added to this 1750 plus 14. It will be 1760 and this 1760 will be the perfect square and square root will be this 42. Okay, so you have to compare just this number. Either it will be less than square of one number and it will be it will be greater than square of number and it will be less than the consecutive number of that, that is 42. So the square root of this 1764 will be 42. Next is 252. It is very simple. This is 252. Put a bar. So this is 152. Double of this is 2. So 25, 5 times we will go 125 and we will look for 26. This is 156. So 156 we cannot write because it is greater than this. So we will go with 5. So here it is 5. This will be 125. So this is 7 and this is 27. So it is understood that this 252, it is greater than square of 15 and it is less than square of 16. Square of 16 is 256. So this 252 and next perfect square number is 256. So what is the difference between two? This is 4. So 4 is the smallest number which has to be added to this 252 to make 256, and 256 square root will be 16. So consecutive number will be there. Clear? Next, is 1825. This is 1825. So bar 4, square of 4 is 16. This is 2. We will write this to 25. Double of 4 is 8. Now see, it's 82 2 times. If we are writing this is 164 and 83 3 times, this will become 249. So we cannot go with this. So we'll go with this 2. This is 164 and we write 2 here. So this will be 1 and 61. So 61 is the remainder. So what we do? This is 1825. It is greater than square of this 42 and it will be less than square of 43. So 43 square will be, so this will be 1849. So our number is 1825 and next perfect square number, this is 1849. So what will be the number which has to be added? This will be 24. So 24 has to be added to this 1825 to make it a perfect square, that is 1849, and the square root of this number will be this 43. Clear? Now the last part of this question. 6412. This is 6412 and we have to put the bars. So perfect, it is a perfect square, square of 8. So this will be, we'll get 0 as remainder, or we need not to write. So double of this is 16 and 12. Clear? So we cannot even try for 1. It will be 161. So it is very less than this. So we will write 0. Okay. So this is the remainder. So what we can say, this 6412 is greater than square of 80 and it is less than square of 81. Square of 81 is, so it will be 6561. So this is 6561. So we have our number 6412 and next perfect square number is 6561. So what is number to be added? We just get the difference of these two. This will be 49. Okay, so 49 is the smallest number which has to be added to the 6412 in order to get the next perfect square, that is 6561, and the square root of this 6561 will be this 81. Okay, this will be 81. So this is 81. Clear? I hope now things are clear. So this was all about question number 5. So next question is, find the length of a side of a square whose area is 441. So square, as you are aware, suppose this is a square ABCD. You know this, every side of a square is equal. So if it is x, it will be x, it will be x, and it will be x. So this is question number 6, right? 6. Side of square be we will suppose x centimeter. So the area of square will be, it is side square, that is x square centimeter square, but according to question the value of this x square is 441. Okay, so x will be, simply if the square of x is 441, so x will be square root of 441. And if you see, you can calculate by any number or by any method, either by prime factorization or division method. X comes out to be 21 centimeter. So the side of square is 21 centimeter. Now question number 7. Question number 7. So question number 7 says, in a right angle ABC, angle B is 90 degrees. So we have a triangle which is right angle at A. So A, B, C and B is right angle. Okay, means it is of 90 degrees. So I have told you side opposite to this angle is hypotenuse. As I have explained in the previous video, this is hypotenuse, this is BC is base, and this AB is perpendicular. I have explained you. So the Pythagoras theorem says, by Pythagoras theorem we have AC square equals AB square plus BC square. So this is the Pythagoras theorem. So first part is, we have been provided with AB. AB equals to 6 centimeter and BC is 8 centimeter. So we have to find AC square. So AC square, we have AB square, that is 6 square plus this 8 square. So 6 square is 36 and 8 square is 64. So it comes out to be 100. So AC square is 100. So AC will be square root of 100, and you calculate, it will come 10 centimeter. So the value of AC is 10 centimeter. Now I hope it is clear because I have explained already in previous videos. Next part is, we have been given AC is 13 centimeter. We have BC 5 centimeter and we have to find AB. So AC square equals AB square plus BC square. From here we will see AB square will be equal to AC square and this will come to this side, that is AC square minus BC square. Okay, AC is 13 square minus BC is 5 square. So it is 13 square is 169 and 5 square is 25. It is come 144. So the value of AB square is 144. Therefore AB will be square root of 144. It comes out to be 12 centimeter. Fine. You can calculate by prime factor or long division method. It is up to you. Now question number 8. Question number 8 says a gardener has 1,000 plants. He wants to plant in such a way that number of rows and number of columns are remain same, or they are same. If there are 10 rows, then there should be 10 columns. So find the minimum number of plant he needs more for this. So he has 1,000 plants and he want to keep number of rows and number of columns equal. So let number of rows x and number of columns will be also x, will be x. So total plants will be x into x. Total plants will be x into s, that is x square, but he has 1,000 plants, so he is not aware whether this is 1,000 is a perfect square, so it should be perfect square. So he wants to know that what number of more plants he should add to this 1,000 so that it will become a perfect square. So it is a case when we have to add the smallest number to a particular given number in order to make it a perfect square. So we have to look for a number which has to be added to this 1,000 in order to make it a perfect square, like we did in question number 5. It is a, also we will see how to find. So again, this is square of 3 is 9, so double of 3 is 6, and 62, 2 times will be 124, so we cannot take 124, so we will write with 1. Okay, so this is 39. So this 1,000 is greater than square of 31, clear, and it will be less than square of 32. So square of 32 will be, square of 32 is 124. It is 120. So we have 1,000 plants and we need 124 in order to make number of rows and number of columns equal. So how many extra plants we need? We have 1,000 and we need 1,024 in exact. So we need 24 plants more. So he has to take 24 more plants in order to make number of rows and number of columns equal. I hope this is clear. Now question number 9, or the last question of this chapter. There are 500 children in a school. For a PT drill, they have to be standing in such a manner that the number of rows is equal to the number of columns. So how many children would be left out in this arrangement? Again, there are 500 students in the school. So they have to be arranged in such a way that they form equal number of rows and equal number of columns. Okay. So we have to, in that procedure, we cannot add more student to the school. So we have definitely have to subtract some student in order to make this 500, or in order to make number of rows equal to number of columns. So we will see, let number of rows be x and number of, so you will write in full. When you are writing, you will have to write the full statement. So the total number of student required will be x square. X square student will be required only, then number of rows will be equal to number of column. So we have 500 students, so we have to check whether this how many students we have to leave in order to make this arrangement. Okay, so we will see, this is 500. So it is similar to question number 4. So 2 square of 2 is 4, and this is, we will write 0, double of 2 is 4 again. So it is 2, it will be 84. So this is the 64. If we subtract this 16 from 16 from 500, if the remainder would have been 0. So that particular number would have been a perfect square. So if we subtract 16 from this 500, we will get 484, which is a perfect square. That means, and the square root of this 484 will be 22. And this 22, this is number of rows as well as the number of columns. So there will be 22 rows and 22 columns, and the total number of student involved will be 484. So the number of student left will be 16. I hope now the concept of square root, how to find by prime factorization or division method is clear. So you can practice some more questions from different books. Okay, so we'll come up with the next chapter, with a new chapter in our next video. Thank you.